So in this video, we're going to learn a new method for factoring quadratic equations called the quadratic formula. You may have been exposed to this in Math 1 or in Algebra 1. So the idea is that there is a formula in which you can find the roots of any quadratic equation. And unlike the box method, and unlike a method that we'll learn later called completing the square, you can use the quadratic formula for absolutely any quadratic that you get. It's really neat in that sense. So let's go ahead and write out the quadratic formula and see sort of where it comes from visually. So for any quadratic equation that I have, the x-coordinate of the vertex is going to be negative b over 2a, no matter what that y value is. And I should go ahead and write out. We must recall, we're going to be seeing a lot of a's, b's, and c's, so we must recall where these actually are in the formula itself, in the quadratic formula. So let's write out the general form of our quadratic equation, which is y equals ax squared plus bx plus c. Okay? So we have negative b over 2a, and that represents our vertex. And so that means that this point right here is negative b over 2a, comma 0, because it is a point that lies on the x-axis. So now, there's another part of our formula that indicates the distance from root to root. So the distance from this from this point, negative b over 2a comma 0, to this first root can be described by the following formula. So let me get a new color for that. Okay, it can be described by square root of b squared minus 4ac all over 2a. In the same way, the distance from this point to the other root can also be described as square root of b squared minus 4ac all over 2a. Alright, so that means that our formula to find the roots is to take this point, this x-coordinate negative b over 2a, and add this term to it to get that root, and subtract this root from it, and subtract this term from it to get this root. So ultimately our formula is going to look like this. I'm going to write it out in black. It's going to be our roots equal negative b plus or minus the square root of, let me make my pen a little bit smaller, the root of b squared minus 4ac all over 2a. So let's look at an example of finding the roots with the quadratic formula. So let's start using the quadratic formula on a relatively simple equation. Oops, didn't mean to be that big. So let me go ahead and erase that, and let's get a smaller pen tip. Okay, so let's do the equation y is equal to x squared plus 5x plus 6. So I know that I need to put this into my quadratic formula, so I'm going to also write that over to the side. So I'm looking at negative b plus or minus the square root of b squared minus 4ac, and all of that is going to be over 2a. So I have what I'm working with and the original equation that I'm given. So what do I put in for a, what do I put in for b, and what do I put in for c? So it looks like a is 1, so a is 1, b is 5, c is 6. So I'm able to enter that directly into my formula. So I'm going to do negative b plus or minus the square root of b squared minus 4 times 1 times 6 all over 2 times 1. Okay, so I'm going to simplify that. I'm going to have x equal to negative 5 plus or minus the square root of 1, because 5 squared minus 4 times 1 times 6 is just 1. And I do all of that over 2. So now I'm going to split that into two parts. I have negative 5 plus 1. Square root of 1 is just 1. I'm going to do that over 2. And negative 5 minus 1. I'm going to do that over 2. So I can actually break that function into two parts to see what's going on. So I can do negative 5 over 2 plus 1/2. And then, so that's my first solution. And my second solution is negative 5 over 2 minus 1/2. And if I do that algebra, I get that x is equal to negative 2, and negative 3. Let's construct a graph to see what that looks like. So I'm going to draw my graph. Okay, and now I know that the roots are at negative 2 and over here at negative 3, so I can draw in my parabola here. So let's think about this negative 5 over 2 and this negative 5 over 2. Negative 5 over 2 is the same number as negative 2.5. And negative 2.5 occurs right here, directly in between negative 2 and negative 3. So what this formula is saying is take this negative 2.5 and add 1/2 in this direction, as in that's what it's telling us here. Then it's telling us to subtract 1/2 in this direction. And if we do that, if we take negative 2.5 and add 1/2 and then subtract 1/2, we're going to get to our roots. So that's fundamentally what this formula is doing. It's giving us the x-coordinate of our vertex, negative b over 2a, and it's telling us, well, add this distance to get to this root, and subtract that same distance to get to this other root. So this is going to be my equation, y equals 1x squared plus 2x plus 8, and I knew that there's an implied 1 in front of that x squared, so I'm going to go ahead and write that in. So I'm going to write it in there. And if I want to, if it's helpful, you don't have to do this. Only do it if it's helpful for you. You can write out what your terms are. So you know that a is equal to 1, b is equal to 2, and c is equal to 8, and you can substitute those in directly into the quadratic formula. So I'm going to do that now. So I have negative b plus or minus the square root of b squared minus 4 times 1 times 8 all over 2 times 1. Okay, so now let's go ahead and simplify that. I could do negative 2 plus or minus the square root of 4 minus 32. Okay, so 4 minus 32. Okay, I'm going to draw my line here. 2 times 1 is just 2. So now I have two solutions. I have negative 2 plus square root of negative 28 all over 2, and I have negative 2 minus square root of negative 28 all over 2. Now, what do I do with these negative square roots? Because I'm not used to thinking about negative square roots as things. In fact, I've been told, you're told for most of the time that you're in school that you cannot have negative square roots. But in reality, you can, and they fall into a class of numbers called imaginary numbers. So when you get a negative square root, you can deal with that by writing it out as follows. So I can say negative 2 plus positive square root of 28, but because I've made that positive, I'm going to put an I beside that to indicate imaginary, and I'm going to do that all over 2. I'm going to do the same thing with my next example, so negative 2 minus square root of positive 28, I, all over, oops, let's do it in a different color. Okay, all over 2. Okay? So the idea when we get imaginary solutions like this is that we don't have real roots. So we don't get roots that are real numbers. We get roots that are imaginary numbers. Graphically, what that means is that we have some parabola on a graph, and that parabola is either completely above the x-axis or completely below the x-axis. Therefore, it never crosses the x-axis at all, so it doesn't have any real roots. So that's what we can infer if we get imaginary roots from the quadratic formula. So these two items are our final answers. Okay, we're going to look at one final special circumstance with quadratics. So we're going to look at the equation y equals x squared plus 6x plus 9. So far we've thought a lot about just basic examples of using the quadratic formula. We've thought about what happens when we get a complex solution. In other words, when we get a negative value under that square root in the quadratic formula. This equation is going to present us with another interesting situation. So we have negative b plus or minus the square root of b squared minus 4 times 1 times 9, and all of that's going to be over 2 times 1, We're going to split that into parts, so it's going to be negative 6 plus or minus the square root of 36 minus 36, get that into a minus sign, all over 2 times 1, which is just 2. So what we actually get is negative 6 plus or minus 0 all over 2. That's equal to negative 6 over 2, and that's equal to negative 3. So what does it mean when I only get one root like that? Well, that's a situation where, imagine we're on this graph, and we're over here at negative 3. So 1, 2, 3. I'm going to make a few more tick marks. Negative 4, negative 5. Okay, that's a situation where we have a parabola that touches the x-axis at exactly one point, which we know can happen. So there are some rare situations where you can actually get one solution from the quadratic formula. That would be a situation where you could rewrite this equation as x minus 3 times x minus 3. Oops, beg your pardon, need to do pluses there. X plus 3 times x plus 3. So we can use our result from the quadratic formula also to write out a factored form of the original equation that we're given. So we've done one example with the quadratic formula, and we've seen two special circumstances now. One where we get complex solutions, and one where we get exactly one solution. That will conclude this video.